Hi, grade fours. I accidentally deleted all of my scenes with a whiteboard explaining what the day is, but I figured this might be a little nice change for you in my work chair. I would join you in my work chair. So, welcome to Wednesday for math. I'm glad that you're joining me for math. Today we are going to do a little bit more fractions and then some other skills that we've been practicing as well. Remember, if there's anything bothering you for math or anything that seems really stressful or hard to do, send me a message on Teams and I will try to help you as best I can, okay? Because I'm here to help. So don't struggle. Don't struggle any more than you have to. I know I always say it is productive to struggle a little bit in math, but don't struggle any more than you have to. I'm here. We can work together. Have a beautiful math time. And I'm not going to put a clip at the end, so I'm just going to say, have a great day. I miss you all, and I'm so thankful that you're following along with these videos and checking in for math on English days. Okay? Have a great one, everyone. I will see you on Friday for more math. Okay, so we're going to work on this word problem for Wednesday. So 1 orange costs 60 cents. You can buy a dozen, which is 12, for $5.99. Okay, which is the better price? And explain. So we are going to think about this. So if each orange costs 60 cents, okay, each orange costs 60 cents. We're going to do 60 times 12. To find out how much that would cost. So the easiest way to do this is 60 times 10 equals 600. Okay, and 60 times 2 is 120. Now this isn't dollars, this is cents. Okay, so it would be 720 cents. Now to figure out how many dollars, you just put a decimal point there. It's $7.20, right? So that is how much it would cost for 12 oranges if you bought each one individually. But if you bought it as a dozen, it would be $5.99. So the better price, I'm going to say the better deal, is a dozen at $5.99. It would cost $7.20 for 12 single oranges. Now, the reason I didn't do this where I wrote it down and I did the standard algorithm, this is the way if you were in a store and you were trying to figure this out, this is the easiest way to figure this out, is to think in terms of cents and then put the point back in because there's 100 cents to every dollar. Okay, so 720 cents is $7.20. Okay, or yes, $7.20. If you bought 1 dozen oranges and used a $5 bill, and a toonie to pay for your purchase, what would the change be? Now, we're going to go with this price. So I think if you bought 1 dozen oranges and used a $5 bill and a toonie to pay for your purchase. Aha, yes, okay. Because that otherwise, if we were buying them individually, that wouldn't be enough money, right? You would a $5 bill and a toonie is $5 and $2. Okay, so the total that you would have is $7. So they must be talking about this $5.99 price because otherwise that doesn't work. So I am going to figure this out by subtracting. So here's what she gave, or I gave. I gave them $7. The cost was $5.99. So now I need to subtract. Okay, you could do standard algorithm, or I could think, okay, I'm going to think $7 minus $6 is $1. Okay, and then I have one more penny. So my change would be $1.01. Nowadays, we don't do pennies, so you would just get $1 back. Okay, so sometimes it's easier if it's $5.99, just think $6, especially if you're in a store. You're like, $5.99, you're trying to figure out, think $6, it's $6. And then you can just, the penny is kind of extra. Okay, what is a straight angle? straight angle. That's all it is. How many lines of symmetry? So how many times could we do a line of symmetry? We could do one this way and one this way. So there are 2 lines of symmetry in H. How many faces does a pyramid have? Okay, so a pyramid has 3 of these things. 1, 2, and there's 1 on the back. 3. And then it also has 1 at the base. 4. So it has 4 faces. Because at the top, the 3 sides kind of rest together like this. So I can't even draw it because this would be a square base pyramid. But the 3 sides, so there's 1 side, 2 side, and then there's 1 on the back that you can't see. So 1, 2, and then behind there's a 3rd. And then you also count where it rests, the bottom. So there would be 4. Can you draw a pair of intersecting lines? Remember we talked about how intersecting lines are just lines that meet. So there is my intersection right there. Can you make a cube with this net? So 1, 2, 3, 4, 5, 6. Can you make a cube with this net? So let's see. How could I fold this up? I don't think I could because these 2 are going to interfere with each other. So no. I could not make a cube with that net. 1, 2, 3, 4. Yeah, no, that's not. Usually when you make a cube, your net has to be, these can't be right next to each other because then they just kind of form a weird, and a net is just if you cut this out, would you be able to fold it into a cube without modifying it? So without ripping it or taking it apart. So no, you would not be able to do that. Now let's practice multi-digit multiplication. So 30, for this, guys, I'm gonna show you another way than I usually do. Okay, so I'm gonna do it a slightly different way than we're used to practicing it, but panic not. You can do it however works for you. So 32 times 8. 8 times 2 is 16. I put my 6 here, and I have a 10. I'm gonna put my 10 up there so I remember to add it, okay? 8 times 2 is 16, and then I go 8 times 30, right? So what's 8 times 3? 8 times 3 is 24, okay? So 24, so it would be 240. Okay, because that's times 10. I have one more 10 here, so it'd be 250. So 256. Now, if you want to do this partial products, that's fine. Just check the answer here. You might want to watch me do this a few times so it starts to make sense to you. Because partial products is awesome, but it is easier if you can do it this way. Okay, now my next one. Okay, now moving on to the next one. 7 times 9. 7 times 9 is 63. So I'd put my 3 in the 1 spot. Remember, this is my 1s, this is my 10s. And then I would just put 6 10s up here so I remember that I need to add them. Actually, maybe I'll put them up here. This is a little cramped. So I know I have 6 10s that I need to add. If I put them over here, I might think they're hundreds. Okay, and now I do my next one. 7 times 7. 7 times 7 is 49. So 7 times 70 is 490. Now I need to take that 490 and add in my 6 10s. Okay, so 490 plus 6 10s is 550. And then it would be 553. Okay, again, if you want to do partial products, if this is like no, keep doing the partial products. I'm just modeling it. 1 times 2 is 2. 2 times 60, 2 times 60, not 2 times 6, but 2 times 60 is 120 because 2 times 6 is 12. You just add a 0. 120. So it's 122. So I'm still doing partial products. I'm just writing it differently, okay? 5 times 1 is 5. 5 times 7 is 35. So 5 times 70 is 350. It's 355. 59 times 3, so 3 times, I start with my 1s. 3 times 9, so I think 3 times 9 is 27. I can record my 1s, okay? And then I'm gonna put my 10s up here. I have 2 10s left to deal with. Then I move on to multiplying in my 10 spot. 3 times 50, well, 3 times 5 is 15. 3 times 50 is just that with a 0. So 150. Plus 20, because I have these 2 10s. right? That's 20. Actually, this might be more helpful. I'm going to put that up there as plus 20. I still have two tens, so I'm going to go 150, 160, 170. So it's 177. Okay, go on to this one. 9 times 3 is 27. So I'm going to put my ones there. And then I'm just going to write plus 20 because it's 27, but I'm not writing my 20 in there yet, okay? So I'm just going to put this in a circle as I still have to add 20 to my total. Now I'm going to do 9 times 5 because I'm going to do 9 times 50, but I start by doing 9 times 5 is 45. And then I think I have a 0 on the end, right? So 450 plus 2 more tens, 460, 470, 477. 68 times 4. So 68 times 4, I do 8 times 4 to start. Excuse me. So I start with 8 times 4, and that's my 1 spot. 8 times 4 is 32. So I'm going to put my 2 in the 1 spot, and then I'm just going to write up here that I'm adding 30. Okay, I'm adding 30. Now, most people would just put 3 tens, but since we're just switching from partial products to this, I'm going to show you. You have 30 there, because if I put a 3 up there, it's going to get confusing. So you pretend that you hold on to that 30 up there. So then you move on to, so I multiplied my ones. 8 times 4 is 32. I put my ones in my 1 spot, and I hold on to those tens up there because I'm going to need them. Okay, now I do 4 times 6. So I think, okay, 4 times 6 is 24. So 4 times 60 is 240. Okay, plus 3 more tens, 250, 260, 270. So it's 272. Now, I can feel some people are going to be a little bit frustrated by this process. Know that if you want to use partial products, I'm actually going to model partial products from my last one, just so you remember the steps for partial products. If you want to use partial products, please do. This is just something that when you get into grade 6, this is how you'll probably end up doing this. But for grade 4 and 5, and even into grade 6, guys, the more you practice partial products, the more this will make sense to you, okay? So don't stress if you're seeing this and you're like, I have no idea what she's doing. You should. If you do partial products, you should be getting the same product. Okay, the last one I will model partial products because I can feel some people were stressed out by this, and I'm going to show you. Either way is fine. So partial products, 3 times 9 is 27. I write 27 instead of putting my 20 up here, right? I just put it right down here. And then I do 9 times 8. Okay, so 8 times 9 is 72. 9 times 80 is 720 because I'm working in this 10 spot. Now I add the 2 together. So I have 7 ones, I have 4 tens, and I have 7 hundreds. So all this is instead of writing this here, I put it up there so that I don't have to make a big list. But for some of you, this is how you really like to do it, and that is completely fine. Actually, this is how I prefer to do it, especially when I get into bigger numbers. It helps me keep everything straight. But there are some of you who probably want to do it Grandma and Grandpa's way, and this is kind of the first step to Grandma and Grandpa's way. Okay? So now you've seen it done. You can pick what works for you. Okay, next side, parts of a set. Parts of a set. So it says, we know that fractions are often shown as parts of a whole like this. So these are all the parts of a whole. So it says, but fractions can also be part of a set like this. So this is a set. And it says, if 2 friends, so this is how we've done fractions so far. Okay, they're parts of a whole. But you can also do parts of a set. And looking here, if 2 friends were sharing these cookies, they would each get 1/2 of the cookies. There are 3 cookies in each half. So looking here, we have 1, 2, 3, 4, 5, 6 cookies total. And we're going to break those 6 cookies into 2 equal groups for their friends. This is division. Look, 6 divided into 2 groups. There are 3 in each group. Fractions is just a different way of looking at division, really. Or this, there are 3 circles. 2/3 of them are shaded. So when we are looking at this, we're taking this as our whole. So this is the whole set. This is the whole set. Okay? If we looked at this, if this is our whole set, and this is what fraction of this set of circles is shaded, you would just go, okay, well, I have 3 circles. and 2 of them are shaded, 2/3, right? 3 circles, 3 pieces total, and 2 of them are shaded. A good way to practice this is with like Smarties or something. Okay, answer the question for each set of objects. So for each set of objects, we're going to answer these questions. How many are shaded? So how many objects do I have altogether? 1, 2, 3, 4, 5, 6, 7, 8 in all. Oh, I always start with how many in all, guys, because I find that bottom number never changes. So that's why I started there. This is how many in all. How many are shaded? 1, 2, 3. So what fractions are shaded? 3 out of 8. 3/8. So when you mark your spelling test and you get it back and there's a fraction there or a number like how many out of 18, that is a fraction, my friends. Okay, so how many are shaded? 1 is shaded. How many in all? 1, 2, 3, 4 in all. What fraction of the circles are shaded? 1/4. Okay, how many are shaded? 1, 2. Again, I like to do it the other way, but I'll go in order of the worksheet. And how many in all? 1, 2, 3, 4 in all. So how many are shaded? 2 out of 4. So again, this one is easier if you think of it like a spelling test. So this could be the amount you got right or wrong on your spelling test. Right, you got this many right out of how many altogether? Okay, now, how many are shaded? 1, 2, 3, 4, 5, 6 are shaded. How many in all? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I definitely could have counted by 2s and made that way easier for myself. So 6/10, 6 out of 10 are shaded. How many are shaded? 1 is shaded. How many altogether? 3 altogether. What fraction are shaded? 1/3. 1/3. Okay. Now, how many are shaded? 1, 2, 3, 4. How many in all? 1, 2, 3, 4, 5. What fractions of circles are shaded? 4/5. 4 out of 5. Okay, so now it's asking you to draw a set of objects to represent each fraction. So 1/4, I'm going to draw 4 objects. 1, 2, 3, 4. And I'm going to shade one of them. And it's going to be this wonky guy here. And then 1/4. Okay, and you guys are going to do the same. So I have 3/5 and 1/2. So for this one, you're going to draw 5 objects and shade in 3. And for this one, you're going to figure it out on your own. How many objects is the number on the bottom? How many shaded is the number on the top? So total. Oh, I guess it would be helpful if you could see. The total number of objects goes on the bottom. Okay, and then the top number is the number shaded. So for an example, if I had the fraction 7/8, I have 8 total and 7 are shaded. I could draw that by just doing 8 circles. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to shade in 7. 1, 2, 3, 4, 5, 6, 7. I've just created 7/8. So these two here, 3/5 and 1/2, I'd like you guys to try those on your own. Please let me know what you think when you're done.